We're gonna make this Pepsi print ad completely in Blender, so let's jump right in. You definitely don't want to model everything yourself. So get a model of a can from Polygon, paid but higher quality, or Blend Swap, free and actually pretty good. I'll be using this one in the tutorial. You can also get the finished file from my Gumroad for $1, and I'll leave all of the links in the description. Throw the model into the scene. I recommend you always use real dimensions, so scale the model as needed, then press Ctrl A and apply the scale. Next we're gonna quickly UV unwrap it, so tab into edit mode and select all of the faces that will have artwork and add them to a new vertex group called label. You may want to lock the vertex group so that you don't modify it later by accident. This allows us to quickly select these vertices whenever we need to, so it's super convenient. Go to the UV editing workspace. With the label faces selected, press U unwrap. This is the default unwrapping that Blender does, but it's not useful for a project, so we're going to use a different technique. Select one of these faces and unwrap it in the same way. Now select all of the label's faces by clicking on the vertex group select button. This will select all of the faces, but will leave the face that you've already unwrapped as the active face. You can see it's in a different color. Press U again, but this time click on follow active quads. The default mode works, so click OK. Now just scale the faces in the UV editor so that they fit in the texture space. If you want a seamless label, go to UV constrain image to bounce. Now place the faces on the bottom left corner. On pivot, select 2D cursor. Now scale the faces all the way up. I'll turn off constrain image to bounce because I don't need it. Go to the shading workspace and add two materials. Name the first one aluminum can and the other one label. Now in edit mode, deselect everything by pressing A twice and select only the label vertex group. Back in materials, with the label material selected, assign it to the selected faces. Now select the aluminum material and make a simple metallic off-white color with a roughness of around 0.3. Select the label material and add an image texture node. With the node wrangler enabled and the image texture node selected, press Ctrl T. Make sure it's using the UV coordinate. Then connect the texture to the color of the principled shader. The color might become black or purple because there is no image selected. We need to create that image texture. You can use any image editing software that you want. I suggest GIMP if you want to go completely zero budget, and Affinity Designer or Photo if you want a good software that you can own and get rid of Adobe's atrocious subscription model. You can also take a screenshot of this. You can use any file size and ratio, but Blender makes the most efficient use of squared images with the size in pixels being powers of 2. So for this project, the ideal file is a squared PNG of 2048 pixels per side. Any way you make the image, save that file to the same folder where you have your Blender file so that it's easy to find. Now go ahead and select that file in the image texture node. In the UV editing workspace, set the viewport shading to material preview so that you can see the texture on your model, and in the UV editor, change the position and scale of the faces to your liking. For this particular exercise, you can go out of the bounds because the whole background is blue. If you scale it too much though, the logo might start repeating or showing on the back. To fix this, go back to shading and change here from repeat to extend. Now turn metallic all the way up and roughness to 0.3 to finish our base materials. We're gonna make condensation in geometry nodes, so go to that workspace and with the can selected, click on new and rename the node tree to condensation. Add a distribute points on faces and a join geometry nodes. Connect the group input to the join geometry node to have both the can and the condensation geometries in our output. At this scale, the points are too big, so we can add a set point radius node and change the radius to 0.2 centimeters. Change the distribution method from random to Poisson disk. Increase the density max to a large number around 6,000. You might see that we have points on the ring of the can, which is something that we don't want. A very easy way to fix this is to connect the density factor to this socket in the group input. You'll see in the modifiers that this new field has been added. Click on this button to toggle attribute input. Now click on the field and we can use the vertex group for the label that we created a while ago. This will tell the node to distribute points only on those faces. Now add an instance on points node. We need to create the droplets to instance, so model a few of them. The more you make, the more realistic it will look. You can use half of a UV sphere for the base and then just use proportional editing to push vertices around and get the different shapes. Turn on face orientation to see that everything is facing the right direction, indicated by the blue color. If you see some faces that are facing the opposite direction, indicated by the red color, just select all of the faces and press Shift N to fix it. Turn the face orientation overlay off. Now select select all of your droplets, press Ctrl A and apply the scale. Now press M and add a new collection, call it droplets. Now back to our can's node tree, drag the droplets collection into the editor space. Tick both of these boxes and connect the node to the instance socket of the instance on points node. Check the pick instance box as well. To give them the right orientation, connect the rotation of the faces to the rotation of the instances. Now if you feel that some of the droplets should be rotated so that they seem to be sliding down on the surface and the thicker part of the droplet is on the bottom, you can select the original droplet model, tab into edit mode, A to select everything, and rotate along the z-axis. Now let's fine-tune the condensation to make it more believable. Add a random value node and connect it to scale. We don't want the min value to be 0 because these droplets will just disappear, so give it a value of 0.1. Now to prevent some of the overlapping, change the distance min field on the distribute points and faces node. I'll go with 0.3 centimeters. There's still a little bit of overlap, so I'm gonna go to 0.4. Now there's still a little bit of overlap, but maybe my droplets are too big, so I'm just gonna reduce the max in the random value node that's connected to the scale. Let's go to 0.7. I'm gonna go even smaller to 0.5. Since we made them smaller, it looks a little bit empty, so let's increase the density max to 10,000. I'm also gonna reduce the distance min to 0.3. If you find any droplets that are on strange places or that look funny, we can change the seed of the distribution until we get something that we like. This one looks good to me, so I'm gonna leave it there. Now we need to give the droplets a material. There are a couple of ways to do this. First, select any droplet, or any model really, we just want to create a material somewhere on our file. Add a new material and call it water. Select glass and give it a roughness of 0.1. Now we can either assign this material to each of the droplets, or we can do it in the geometry nodes by adding a set material node. We'll place it here, and we select the water material that we just created. We can also add a set shade smooth node. We can now hide these droplets by unchecking this box. That will also ignore them in the rendering. Now let's build our scene and a basic light setup. Add a plane and extrude the back edge on Z. Select this edge, Ctrl B, drag the mouse away until the beveled edge is close to the can, then mouse wheel up a few times, left click to accept, tab out to object mode, right click and select shade smooth. Add a material, call it background, and give it a color that you like. I'll go with a metallic dark blue. Now go to the world properties, surface, strength all the way down to 0. This will remove the world lighting. Delete any default lights on your scene. Add a couple of area lamps and point one to the side and one to the front in diagonal. Place the view in a place close to where you want the camera to be. Then press Ctrl Alt 0 on the numpad. Grab the camera and adjust its position to something that looks good to you. Now drag here to add a new 3D viewport. Hide the gizmos and overlays, press T to hide this sidebar, and press N to hide the side panel. Now in this window, go to rendered view. Lighting is the most important thing in product shots, so play with your lights to achieve a look that you like. I've seen artists that use dozens of lights, artists that use a traditional 3-point lighting rig, some prefer HDRIs, so there are really no rules, but my only piece of advice would be to use as few lights as possible to achieve your creative vision. I do suggest though that you use light linking and have dedicated lights for each element. So let's do an example. I'm gonna select one of these lights, go to object properties, shading, light linking, add a new collection and rename it to can LL for light linking. Now drag and drop your can to that collection. I'm gonna rename this plane to background. Now select the other light, click on this icon and select can LL. Now these two lights are only affecting the can and not the background. Add a sun lamp and link it to the background plane. Change its strength to a smaller value, something like 0.1. Now we have this nice effect where the can pops out of the scene, which can only be achieved with light linking. Now let's go back to our shading workspace and select the can. Change the viewport shading to rendered. When cans are ice cold, they not only get the visible drops of condensation, but also tiny droplets that we can fake with materials. In Sheen, slide the weight value all the way up. Now play with the roughness until the sides look frostier. Here there's one very cool thing that we can do. Go to texture paint and add a new image. 1024 is okay. Rename it to drip map. Go back to shading and add another image texture node. From this menu, select the drip map image that we just created. Now connect the vector to the UV coordinate. Connect the color to the roughness of the sheen and add a color ramp. Back to texture paint, make sure that drip map is selected and paint a trail for any of the droplets that are closer to the edge from the camera view. Back to shading, we can see that the trail is in fact having the opposite effect, so flip the color ramp. Now you see that there's a trail where the drop removed the tiny condensation particles because it was sliding on the surface of the can. Now we need to adjust the white color on the ramp. So click on it and slide this down until you get an effect that you like. Now back to texture paint and add a couple more trails to really start selling the image. One thing to note though, when we did the UV unwrapping, we extended past the bounds of the texture image. That's something we should try to avoid. And the reason is that, for example, I paint something here, you see that this appears in both sides. And if I rotate the can, it's also here. So keep in mind for future projects, you'd rather modify the texture than extending the UV unwrap out of those bounds. When you do this, if you go to the rendered view, you'll see that if I paint something, the stroke appears in the image editor, but it doesn't update in the rendered view in real time. You can go to another workspace and then click back, and now you can see it. Also, remember to save the drip image, as it does not save automatically. If you see an asterisk here, it means that you haven't saved, so click here, save. This right now is starting to look pretty good, so let's give it a quick render to see our work. Go to the render properties, reduce the max samples to 128 or so, and uncheck the denoiser. I love the denoiser and it really makes magic for most of your images, but for this specific scene, I think I like it better with the noise. Now render the scene, observe the image, and just think about it. What do you think could make it look better? This is where you become your own critic and creative director. So at this point, adjust anything you need, and then let's move on. This is my render after creative direction. I added a little bit more condensation, changed some values of the material. I also moved the lights a little bit and the camera as well. Now let's add text and write our slogan. Center the alignment and select a font you like. I'll just go with Verdana Bold. I want to reduce the line spacing a little bit. Now scale it and place it behind the can in a position that you like. Go to shading, with the text selected, add a new material, add an RGB node and connect it directly to the output. This way we don't even need to set any lights for the text. Finally, let's make a splash. If you're using the blend swap model, it comes with shape keys so that you can easily close it and open it. We want to open it so that the splash can come out of the bottle. If your model doesn't have an opening, you can either modify it so that there's a hole in it, or you can go all Hollywood on it and just place the camera in a way that you cannot see the opening. We're gonna close this panel for a second, and we're gonna use all of this space. Now keep in mind that liquid simulations are a whole science on their own, so I'm gonna breeze through this part to keep the video relatively short. Add a cube and move it to the right. This is going to be our domain, the space where the simulations are calculated. We need a larger size like this, and that's why we don't do it directly in the can. We're gonna make a splash in a big size and then scale it down and put it on our scene. With the cube selected, go to the physics tab. Now click on fluid and select the type domain. Now from this domain type in the settings, change from gas to liquid. Create a UV sphere and scale it down. Go to wireframe mode and place it near one of the lower corners. We want it to be close to the corner because we're going to spray it this way, and the idea is that we want to use most of the space of the domain. Now with the sphere selected, in physics, click on fluid, and now we're going to select the type flow. Flow type will be liquid and flow behavior inflow. Now select the domain again, scroll down here and click on this mesh checkbox. Make sure that you have a visible timeline because we're going to be needing it. Alright, this is our basic setup for the simulation. If we press spacebar now, we can see the liquid starting to flow from the UV sphere. And as you can see, the water cannot escape the domain. Now from here on, the process is going to be very raw and with some trial and error. It's also a little buggy, but in the end we'll get a very cool result. Select the UV sphere and in the physics tab, check initial velocity. Change the initial values to 2, 2, and 5. Now go back to the first frame and play the animation. In fact, for this project, we don't need the water to collect inside the domain because we're just going to use the splash. So select the domain, scroll down a bit, and uncheck all of the border collisions. Now if you play the animation again, you'll see that the water just disappears when it goes out of the domain. We're gonna be using the timeline a lot, so just remember that space plays the animation, space again stops the animation, shift left arrow key takes you back to the first frame, and the arrow keys by themselves move one frame. Now I think that this amount of water is enough, but you can change the size of the UV sphere if you want more or less water. Now let's add a plane. With the plane selected, in the physics tab, click again on fluid. This time the type is going to be effector. Make sure that the effector type is on collision. Since this is not a closed volume, we're going to check is planar. We're going to use this as a collider to create a little bit more chaos on the splash. If I play my animation again, you can see that the water crashes on the collider. This doesn't really look like a nice splash, so we need to play with the angle and the position of the collider, as well as the size of the source and the initial velocity of the liquid. Once you get to a shape that you like, select the domain, increase the resolution, and run your simulation again. This will give you more realistic results, although not necessarily better. So try different resolutions and see what works best for you. Now, once the simulation is in the cache, you can easily go back and forth. The idea here is to select the frame where the shape looks the best. Now, we're gonna commit to this shape, so you might want to save this file and then save as incremental. This way, if you ever want to come back to your simulation, you still have it. Now, we're gonna go to modifiers and apply the fluid modifier with Control A. We can go here to particles and delete this particle system. I'm gonna delete my collider. I'm gonna go back to solid view, and now we have a mesh that we can work with. Now, the thing with simulations is that the topology that you end up with is pretty ghastly. We can get better geometry by using the remesh modifier set to smooth or voxel and adjusting the voxel size or the octree depth. The other option that we have is to use the paid add-on called Quad Remesher. I do know that most people like to go zero budget, but it's still worth a mention because for me, this is the best option. This is the mesh that I ended up with. I can add here a subdivision surface, shade smooth, and this looks pretty good to me. As it's a mesh, you can of course go in edit mode, and if you want to delete some of these droplets, you can just select them with L and get rid of them. So go ahead if you want to do any of that. I'm just going to leave it as it is for now. Now I'm going to resize it and place it in its position. Now with the splash selected, let's go to materials. If you see any material, just delete it and create a new one. Rename it to Pepsi Liquid. Change the surface to glass. Now change the color to a pale pink and the roughness to 0. Add a point lamp close to the splash and increase its radius a little bit. Let's reduce its power to 1 watt. We're gonna link this light to the splash, so rename your splash mesh if you haven't done so already. Select the light, add a new light linking collection and drag the splash. Rename the collection to Splash LL. Now let's go to our camera view, rendered viewport shading, and now we just need to play with the color of the light, the intensity, the radius, and the material of the liquid to get something that we like. I added a couple more lights because I was having trouble getting the reflections. Now give it a quick render to see your work. From here on, you can do anything you want. Add a few ice cubes, a little puddle of water, more condensation, change the lighting, change the background color, make it Red Bull instead of a Pepsi, and whatever your imagination takes you. And the most important thing, have fun. I'm Dude Blender, happy blending.